Okay. I'm telling you, don't know how to act at all. Yes or no? Is that a quadratic? Why?
There's no why.
Okay. Yes or no? Is that a quadratic? Why? It has a y and an x, a regular number, but so does y equals 2x plus 3. And that's not a quadratic. Tell me what it means to be a quadratic, because I don't think y'all got it.
It's a parabola.
Okay, in the terms of an equation, how do you tell that that's a quadratic? Y'all are telling me yes, but an x is squared. Oh, an x is squared. I'm sorry. I can't tell where things come from, but I can hear them. An x. I don't see an x squared here. If you multiplied it out, it would be squared, right? Do we all agree? Can everyone in here take this from the way it's written, which looks kind of like an intersect form, into a standard form situation? I hear yes and I hear yeah. Okay, so let's talk about what we do. We're going to FOIL, but I don't like to say FOIL. I like to say FOIL. Just kidding. I like to say distribute instead of FOIL because that was a joke and nobody even laughed, but that's all right. Thank you. I appreciate that. All right. We're going to start with the first term, and we're going to distribute it to everything in the second parentheses. Okay, so 2x times x is 2x squared. 2x times negative 3. Great day. All right, so now that first term has touched everything in the second parentheses. So now I'm going to stop with that, and I'm going to move to the next term. And now I'm going to distribute that through. 1 times x and 1 times negative 3. So you see, even if there was more terms, I could keep going. It doesn't, FOIL only works when it's 2 and 2, two pieces. It doesn't work whenever anything gets any bigger or smaller. But distributing always works. Okay, so now I combine like terms. Which ones are like terms? Which gives me what? Which gives me what, Kay? X minus 3. Now does it look like a quadratic? Yes. I combine these two. Negative 6x plus x gives you negative 5x. Okay. So everybody can agree this is something we've done before, right? We've taken it from 2 binomials down to a standard quadratic. Well, what we're going to do today, we're going to take it from here to here. And to do that, we're going to do something called factoring. Okay, so distributing takes us from the parentheses down to the standard form. To go from the standard up to the parentheses, we're going to factor. Y'all remember factoring? Okay, you know, it's okay. Before I teach you to factor, I need to go over some background information. This is going to be really easy. It's going to make you feel like you're just way ahead of everything because you will already know the answer to all these questions. But just to make sure, what is this? Oh, look at there. Okay, not only what is it? You ate. No crumbs. Okay, third block laughs, and we all do it, and we have fun. Y'all have to have fun with that a little bit and laugh. Okay. Greatest common factor. It doesn't matter. That's what makes it funny.
She's still slave with that.
Thank you. Thank you, Logan. Bonus points for you. Okay, so it's not enough just to know. I'm just kidding. Am I kidding though? I am. I'm just kidding. Okay. I like teaching this a lot better than graphing. Can y'all tell? I don't like the graphing at all, but we're past that now. Okay, you told us it was greatest common factor. What does that mean to be a greatest common factor? You're the greatest. Okay, but different greatest this time. Greatest means biggest. Biggest what though? What does that mean? So you got it. Goes into it. Goes into it. Goes into it with no remainder, right? Biggest thing that goes into it, no remainder. So let me give you a couple. We're gonna start easy and then we'll get a little bit harder. I probably would. I would. Greatest common factor of these two numbers. Nope, 15. Biggest thing you can divide them both by, no remainder. I can still divide them by 3. 3x. Still 3x. Still 3. What does x squared mean? 2 x's. So I can still divide it by 1, so it's still 3x. Now, let me make it a little bit harder. If I have 3x squared plus 6x, and I tell you to factor out the GCF, okay? Factoring is backwards distributing. Remember, we're going backwards from distributing. You already know the GCF is what? 3x. So undistributed. Okay, so what do I mean? Divide it. It's going to go on the outside because I'm undistributing it, right? What's left? What would need to go inside so that when I distribute it, I'd be back to what I started with? X squared plus 2. I'm just dividing each one of those. Do you see that? This is the most basic form of factoring, and it's factoring out a GCF. That's too easy. Does that quadratic have a GCF? Yes. It does. What is the GCF? 3. Take it out. Take it out. What does it look like when you undistribute the 3? Put it on the outside. What's left inside so that whenever I do distribute it, it's back to what I started with. Oh. Well, I knew all that yet. If you can GCF, you can factor using the method I'm fixing to show you. Okay? You can't? Yes, you can. Yeah, so I'm looking for the biggest thing that I can divide them all by. They won't always have something, but sometimes they will, and you have to be able to spot it. Somebody had a hand up over here. Okay. Okay. What? Does it have a GCF? 5, not just 5. 5x, because everybody's got an x to give. Undistribute that. GCF it. Doesn't sound very nice, does it? Take the GCF out. GCF it. 5x. So what's left? And all we're really doing, if distributing is multiplying, then undistributing is dividing. So that's all we're doing is dividing each one by the GCF and telling what's left. You took an x out of everybody. Remember, whenever you distribute it back through, you have to be back with what you started. What time does the bell ring in here?
25.
Oh, goodness. Y'all got to keep me on track. Is it 11:20?
It's 11:20.
All right. Now, Yeah.
Oh, yay!
Yeah.
Hooray! I'll tilt that.
No.
You know food guys? That's my dog.
Was that a joke?
No, it's a real person.
I don't know.
This would be, do you need security in the club? No. Dude, what? Never we talk about that stress.
I'm going to run an example along here, and I'm going to put the steps beside it on how to factor. Here's what we're going to do. Once you get it, listen, some of you are going to look at this, and you're going to get so frustrated, and you're going to go, I'm going to get this, and you're going to watch us do 2 or 3 examples, and then it's going to click. Some of us, it'll click quicker than others. Don't shut down on me. Don't give up, because I promise you, when you leave this class, you'll be able to factor in your sleep. This is like a concrete. Okay. All right, here's what I'm going to do first. The very first thing that I'm going to do every single time before I factor, no matter what it looks like, is I am always going to check for a GCF. If it has it, take it out. If it doesn't, skip to step. Oh my gosh. Skip to step 2. Thank you, Logan.
Yeah.
Wait, you didn't set it up right. No, with the chart.
Okay, so now, step 2. Does this have a GCF?
No, it does not.
No. There's nothing I can divide all the numbers by and they don't all have an X. Yes. What? Do I need some? I've been talking to, I still got a third of a cup. I've been talking a lot. I'm sorry. Well, but it'd be a shame for you to miss factoring though. All right. Here's what I'm going to do. Here's where it starts getting confusing and here's where the puzzle comes in. And if you think about it like a puzzle, it'll make it a little bit easier. I do too. I'm going to multiply. Remember, we're backwards foiling, right? That's essentially what we're doing. We're backwards distributing, backwards foiling. We're going to multiply the first and last terms together. Not just 4, but 4x squared. And here's the puzzle part. We have to find 2 things that multiply to this, but they add to the middle term. It is. This is the hardest part. If you can find these 2 things, downhill from there. Okay. So think about this for just a minute. Look at the first side there. What 2 things multiply to 4x squared, but add to 5x? 1x and 4x. Do you agree or disagree? If you multiply 1 and 4, you get 4. If you add 1 and 4, you get 5. Okay? So here's what I'm going to do. I am going to rewrite the middle term. If this is the same thing as 5x, then all I'm going to do is split 5x up. I'm going to write this as 2x squared plus 1x plus 4x plus 2. I haven't changed anything, right? I just wrote 5x different. It's like instead of writing 6, writing 2 plus 3. Same value, same thing. I just wrote it a little bit different. This is my favorite step. I don't know. It's always different every time I do it because we just slash it. Sometimes whenever I slash, I go. I taught a class one time where nobody could remember to slash, and every time we go, and so then we'd be doing their test, and I hear. Okay, slash it in half. Okay, so we're gonna look at this as 2 separate problems, so it's a little bit easier to work with. All right, so we got it slashed. Now what I'm gonna do? I'm going to GCF the first half, and I'm going to GCF the second half separately. Now, if something ever does not have a GCF, what's always a GCF of everything? 1. Good job, y'all. All right, so let's GCF each half here. What can I take out of, or what's the GCF of 2x squared and 1x? 1x. Take it out. Undistribute it. What's left? Take out a 1x, and what's left? Just these first two. 2x plus 1. Good job. Okay. Now GCF the second 2. And, all right, I'm going to bring this middle sign down, by the way. I didn't put that in there. 2. What's left when I take the 2 out? 2x plus 1. What do you notice? They're the same thing, and they should be the same thing. When you get to the point where they're the same thing, now we're going to factor out that whole, we're going to look at that whole 2x plus 1 as being a GCF. And we're going to take it out. So we're going to factor out the binomial. But really all we're doing is we're taking this, writing it one time in the front, and then what's left if I take that out? If I take that out, what's left? X plus 2. And it's factored. Binomial just means 2 pieces, 2 terms. I'm taking, okay, so if this was x times y plus 2 times y, and I said, what's the GCF, what would you tell me? Look at this. xy plus 2y, what's the GCF? Y. Right? They both have a y. And if I took that out, what would it look like? That's exactly what I've done, but the y is 2x plus 1. I let y be a whole chunk of stuff instead of just one value. So I took this whole chunk and pulled it out. If that confuses you, just know when you see it twice, write it once, scratch it out, and write what's left. The order does not matter because multiplication is commutative, so I could write it in any order. So if you got it this way or you got it this way, either one would be a-okay. Either one of those is fine. Either one of these is the answer. You write it one time in front, slash it out, and then what's left, x plus 2. Let's do another. No, because after you GCF it, then you have to go through and factor it. I'll do one like that in a minute. Let me get this one. All right, step 1. Does it have a GCF?
No, 1.
Okay, bigger than 1. Does it have a GCF other than 1? No. So now I'm good to go ahead and go on. So what's my next step? Multiply the first and the last together, right? What's 2x squared times 15?
30x squared.
30x squared. What multiply? Here's where you have to be careful because I got some sign issues here. I got to have 2 things that multiply to 30x squared, but what do they need to add to? Negative 11x. Negative 6x. Negative 5. It's got to multiply to this, but it's got to add to this. Now what do I do with those 2?
You replace the middle.
I replace the middle term with those 2. So now I have 2x squared minus 6x minus 5x plus 15. What now? Somebody do it. You don't actually spit. You just kind of... Oh, my goodness. Okay. GCF both halves now. What about the first half? 2x, what's left? And look at y'all go. Now here's, be very careful, I told you this middle sign comes down. So really I'm taking a negative out here whenever I do this. What's the GCF there? 5. But when I take this 5 out, I'm actually taking a negative out. So what's left? X minus 3.
If you would like to play, you must sign up in the Commons area during your lunch this week only. Any girl volleyball players who want to coach the boys should also sign up during your lunch this week. Any student who's interested in taking a free online SAT, ACT prep course through Princeton Review can speak with Ms. Huff for more information. Today in sports, wrestling travels to
This sign in
Gilbert.
front of what?
Boys tennis will begin practice on Monday, January 30th.
When the middle sign is
Anyone
negative,
interested can
it's
contact
minus.
Ms. Bates from the stand for additional information.
Oh, that's just an asterisk.
The wrestling team will have a barbecue plate fundraiser on
What's
Thursday,
the common
January 26th.
binomial here?
$10 and the dinner includes barbecue, hash and rice,
Take it out,
bread,
write it one
baked beans,
time.
a roll, and a cookie.
What's
You
left?
may purchase from Coach Connell, any member of the wrestling team, at the Wellness Center
Order doesn't
or
matter.
House Street Grill. For lunch today, we have chicken fajitas, barbecue sandwiches, peanut butter and jelly bags, hot dogs, and Caesar salad. That's all for today's announcements. Go Dogs.